Hello students. Today we are going to be going over the common assessment number 2 for your corrections. I will walk you through some problems. Feel free to follow along and use this video to help you set up your problems that you miss on the common assessment. So today we are going to be using the Pasadena ISD problem solving model. A couple of you might have seen this already. We usually call it APE. The A stands for analyze, P stands for plan, and the J stands for justify. You can come back to these slides to ask yourself these questions to help you solve each of these problems as we move along. I am not going to solve the problem completely. I am just going to help you set it up. But again, make it a custom to start using this whenever you are working with word problems. Number 1, select all the true statements. I'm going to highlight my question. The important word here is the word all. So we know that by analyzing, we know that we have multiple answers. Whenever I plan, I'm going to work out all the answer choices and eliminate the false ones. And then to justify and evaluate, that's you doing the math. So do the math. So just a couple of reminders. We can use different sign subtract, same sign add, and we keep the sign of the larger. So for this problem, that's all the information you need. Question number 2. The chart below shows a yard gained by the receivers in a football game. How many more yards did Chad and Felix gain than Terrence? So analyze this problem, this question. How much more or how many more means we need to subtract. And we are going to, when we're planning, we're going to add Chad and Felix. And we are going to subtract that from, we're going to subtract Terrence from them. Again, to justify this, you can use same sign add, different sign subtract. Remember that when you are also subtracting rational numbers, you do keep the first number, you change the sign from subtraction to addition, and then you change the third number to its opposite. So if I have a -2, it becomes a +2. And also, whenever you are adding fractions, you need to have common denominators. So that goes in hand with planning. So right here, I'm using words for right now, but what you would do is whenever you're analyzing, you can just write what I just did, subtract. Whenever you're planning and solving, that's when you can start adding the fraction or set up an equation that might work for you. And then from there, you can go ahead and justify by solving the equation or the math that you are setting up. Number 3, triangle ABC is similar to triangle FGH. What is the value of x in centimeters? So I'm analyzing this. I know I have similar figures. And then when planning and solving, we know that we have to find x. So I need a proportion. There's two different ways you could solve this proportion. It could be by corresponding sides or by adjacent sides. I prefer adjacent sides. Those are sides that are just next to each other on the same figure. So I'm going to use triangle ABC, and my proportion is going to have triangle FGH. So I'm going to help you set up this proportion. Since I know I'm finding x is in triangle FGH, so I'm just going to lay it out there. And I'm going to color my corresponding sides. This side corresponds to this one. And then I could use an adjacent side, which in this case I'll use the 13.5 and the 9. So on this first side, I put my measurements for the first triangle, which is ABC, and then on the next one I should have the corresponding sides for that triangle. The x corresponds to the 15, so I'm going to write it with the 15, and the 13.5 corresponds to the 9. So orange with orange, red with red. After that, cross multiply and divide. Question number 4. The distance between two cities on a map is 3.5 centimeters. That map uses a scale which is 1 centimeter to represent 20 kilometers. What is the actual distance between these two cities? So as I'm analyzing this problem, I know that I'm finding a scale factor. So this is a scale factor problem. And to plan and solve, I am going to draw my big H. I'm going to write my word ratio. I have centimeters and kilometers. And right here, I'm going to write model over actual. And then here we put the scale. When you justify, you write the numbers in. So now I have the model is 3.5 centimeters. And the scale says that 1 centimeter equals 20 kilometers. I only have one space, so I call that x. Again, cross multiply and divide to find your answer. Problem number 5. Figure JKLM is similar to figure PQRS. Which proportion must be true for these figures? So again, similar figures. Planning and solving, find corresponding sides. And also go through every proportion to see if it's true. The way I like to solve these, I usually keep myself organized by listing the letters in the order that they give them to me. So in this case, I have JKLM, and I make a list, JKLM. And I know that those are going to correspond to these other letters in that same order, PQRS. J corresponds to P, K corresponds to Q, L corresponds to R, and M corresponds to S. So from here, what I'm going to do is read all of these proportions and determine which ones are established through adjacent sides and corresponding sides. If one of them does not have a corresponding side where it has to be, then that should not be your answer. Question number 6. Doug is planning to build a model of a sailboat using a scale where 2 inches represents 25 feet. If the sailboat has a height of 210 feet, what is the length in inches that Doug should build the sailboat of the model of the airplane? So, another scale factor problem. Notice how I'm analyzing this problem and determining what type of problem each problem is based on the information given. Plan and solve, I'm going to write my word ratio. In this case, it's actually, let me just write the anchor chart. So my word ratios is inches and feet. It says that the scale says 2 inches represents 25 feet. And we know that the sailboat's actual height is 210 feet. We were missing one spot there in inches. Go ahead and cross multiply and divide. Question number 7. The two parallelograms below are similar. What is the length in inches of PQ? So we're dealing with similar figures. Plan, proportion. So I'm gonna set up that proportion for you. We know that this side corresponds to the longer side, and this one corresponds to PQ, which is the value we're looking for. So I'm going to put the smaller parallelogram on my left proportion, 12/16, because I'm using adjacent sides. You could do it with corresponding sides. Whichever way you would do it, it'll work out. And 12 corresponds to 30 because those are the red sides. And 16 corresponds to X because those are the orange side. The other way that you could solve this or make a proportion is, again, by corresponding sides. This is by corresponding sides. So 12 corresponds to 30, so I will put them as a fraction. And 12 belongs to the parallelogram with 16, so 16 is going to go on top. And X corresponds to the parallelogram with the 30 inches. So again, cross multiply and divide. And notice that the numbers you are multiplying by has not changed. It's still 30/16 and 12 times X. This is by adjacent sides. Go ahead and just evaluate and justify on your own. Question number 8. The diagram below shows a scale drawing of Emilio's desktop. The actual dimensions of the desktops are 50 inches by 30 inches. What scale factor was used to create the scale drawing below? So scale drawing problem. We know that we can do model over actual or new over old to find our scale. So in this case, I could take any side, and usually it's length times width. So that's how they set up these words right here. So that's also in hand with analyzing. So I can take any of these sides, and I know that the model is, I'm going to use this width side. The model is 1.5, and we know that the dimensions are 30 inches. So all you have to do is use needle or numerator in, denominator out to solve that problem by division. Question number 9. Last month, Paige opened a checking account with 125. For 2 consecutive weeks, she deposited $50. She also wrote a check for $27 and another for $35. What was Paige's available balance after the transaction? So this is rational numbers, adding and subtracting. So our plan is to identify our numbers. We can combine the negatives and combine the positives, and then different sign subtract, same sign add. So I have taught my students to make a chart whenever it's a word problem, so it can make it easier. So we know that she opened the account with 125. That's a positive value. And for 2 consecutive weeks, the positive means add money. So she added $50 for 2 weeks. So 50 each week. We have week 1, week 2. Then she says she wrote a check. When you write a check, you are losing money. So that is negative. Notice how I'm also text coding. So $27.50. And another one for $37.75. And then it says, what was Paige's available balance? Notice how we have 2 sets of numbers. We have a positive set. We're going to combine these because these are same sign add. And then we're going to have two remaining numbers. And from those two remaining numbers, we are going to use different signs subtract because we have a positive and a negative number. Keep the larger. The record high temperature of Boston is 104 degrees Fahrenheit. The record low is negative 18 degrees Fahrenheit. What is the difference between the high and the low? Keyword difference. We are subtracting. So you're going to come up with a plan by yourself and determine if that number is positive or negative. So we are going to use same sign add, different sign subtract. Quadrilateral GHGEF is scaled copy of quadrilateral DCAB. Select all of the true statements. So we know that this is a similar figure problem. So you know that you are going to be using proportions. You do adjacent or corresponding proportion. And this is just an easy true or false. And also multiple answers because of the word all. Question number 12. Rolando started recording the temperature in his hometown. On Thursday, the temperature was 25 degrees. On Friday, the temperature was 15 degrees. And on Saturday, the temperature was negative 7 degrees. What was the change in temperature from Thursday to Saturday? So we are working with integers in this, which is just adding and subtracting numbers. So on Friday, I'm not going to solve this, but you would take it one day at a time to see how much the temperature changed. Again, you could do Thursday minus Friday. After that, you do Friday minus Thursday.